Okay, so we're going to talk about the central limit theorem with proportions. We can recognize that we need to use this information if we see percents in our word problem or some sort of proportion. So we're going to have to read carefully and look for those key words to tell us when to use this information versus any other formula. Okay. All right, so a population proportion is basically a characteristic of a population. All right, we use a P for the population proportion, and to find it, we just take X and divide by big N. Okay, X is the number of people with that given characteristic, and N, big N, is the number in a population. All right, sometimes P is given to you in a word problem, and sometimes we need to figure it out. Okay, a sample proportion is just a sample with a characteristic. All right, we call this P hat. All right, and that's because the formula for this is P, but we give it a little hat. Okay, so P hat equals X over lowercase n. X is still the number of people with that characteristic, but lowercase n is the number in a sample. Okay, so if the conditions of a binomial distribution are met, which means, so here's your conditions. We have two outcomes. All right, we have P, which is success, which in our case means they have the population characteristic or proportion. And Q is failure, or that they don't have that characteristic. All right, so this is no gray area. Either you have it or you don't. Okay. Also, the sample size has to be large enough. Okay, and to check and see if that sample size is large enough, it's not just 30. We have to do N times P, and that has to be greater than or equal to 5. Also, N times Q has to be greater than or equal to 5. Okay, so if those things are happening, then we can use the normal distribution to approximate the sampling distribution of sample proportions. All right, the mean, so the mean of this stuff is going to be our P, or population proportion. All right, standard deviation. All right, this is P times 1 minus P over N. All of it is under the square root symbol. 1 minus P is the same thing as Q. So you can think about that formula either way, and that should be fine. Okay. The formula for the z-score is pretty different. Okay. We're going to do P hat minus P, and that's going to be over our standard deviation. Okay, so if we think about the formula, it's really not all that different. This is our standard deviation. All right, this P is our population characteristic, and this P is from our sample. All right, so the concept is not different than what we're used to, but it does look a lot different. This is an important formula I would make sure I could have written down somewhere I can go back to when I'm doing my problems and work, okay? All right, so let's do an example. Okay. In a conservative precinct, 70% of the voters are Republicans. A random sample found 100 voters for a survey. Okay. All right, so in this information, 70 is our mean. Okay, so we would say 70, oh, excuse me, not 70, 70%, which I should really say, we're going to say is 0.7. We're going to use the decimal versions of these percents, okay? So this time it was given to us. We didn't have to do a formula or anything. The information was given to us in the problem, okay? All right, side note, if P is 0.7, then Q would be 0.3 because 1 minus P equals Q. To check and see if we have a big enough sample, I need you to do N times P, make sure that's greater than or equal to 5, which would be 100 times 0.7, so that works. All right, I would also need to do N times Q greater than or equal to 5, and that is 30, so we're good to go. Okay, so if you're asked if we can use this information, that's how we check it, okay? All right, back to the problem. Standard deviation. All right. So that formula says P times either Q or 1 minus P over our sample size, so 100 there. All right. We're going to get some small standard deviations. Do not round too much as you're doing your work. Let me just double check what I have. All right, we're good to go. Okay, what is the probability that at least 68% of voters would be registered Republicans? So this comes from a sample. So this is P hat. And P is 0.70. We can say that our standard deviation is 0.0458. Okay, so we're going to use our new formula for Z. So I have P hat minus P over, and I can either put in the formula for standard deviation or I can go ahead and put in that decimal that we found previously for standard deviation. Just don't round to 0.05. Okay, that's going to throw us off. All right, so here I'm getting negative 0.44 for Z. Okay, let me just double check that. Yeah, okay. So now we want to know the probability that at least we're getting that. So that's actually the probability that our, how would I word that? Probability would be greater than that 68%. So we need to find the area to the right. Okay. All right. So we are still going to use that same table for Z. Okay. That doesn't change. All right. So let's see, we have negative 0.44. All right, so it looks like we are in this column, 0.3300. All right. So the area to the left is 0.3300. To find the area to the right, now we subtract 1 minus 0.3300. So my answer is 0.6700. Okay, since we're doing the area to the right, we gotta subtract there. Okay. All right, what is the probability that the sample is between 0.70 and 0.74? Okay, so we have two P hat values, so we would need to find two Z scores. Okay, now if the P hat value is the same thing as P, this is right in the middle of our standard distribution distribution. So 0.70 is right here. So that corresponds to a z-score equaling 0. Okay. If you do the formula, you'll find 0, but we can just recognize those things are the same, so that z-score will be 0. I still need to find a z-score for 0.74. So I'm going to say 0.74 minus 0.70 over 0.0458, our standard distribution. Okay. And I'm getting 0.87. All right, and we want to figure out the probability that we're between these things right here. Okay. All right, so I'm going to find the area from the left of 0.87, and I'm going to subtract the area to the left of 0. Okay. All right, so if I go to 0.87, all right, that area is 0.8078. All right, the area to the left of z equaling 0 is 0.5. So my final answer would be 0.3078. Okay, there's my final answer for that one. All right. All right, it is estimated that 8.3% of all Americans have diabetes. So there's P. I'm going to say 0.083. We have a sample of 74 Americans. What is the probability that the proportion of the sample of diabetes is less than 0.91? So there's P hat, 0.091. We want to know less than, so we're finding the area to the left. All right, so let's find a z-score. So I have P hat minus P all over big square root P times 1 minus P all over N. Okay. So this is going to give us 0.25. So I need to find the area to the left of 0.25. So I have 0.5987. That's an answer there. Okay. What is the probability that the proportion of the sample has diabetes is between 8 and 9%? So I have a P hat of 0.08 and I have a P hat of 0.09, and we want to figure out the probability that we're like between these two things. Okay, so here's 0.08 and 0.09. All right, so let's find some z-scores. All right, so our z-score for 0.08 is negative 0.09, and then our z-score for 0.09 I'm getting 0.22. All right, so I'm going to find the area to the left of z equaling 0.22, and I'm going to subtract the area to the left of z equaling negative 0.09. All right, and that's going to be my answer. Okay, so 0.22, oh, we're still right there. 0.22, so 0.5871. Yep. Minus, all right, now I've got to go to the negatives. Whoops. 0.09. All right, so that's going to be over here, 0.4641. All right, so this final answer is 0.1230. All right. Okay, last problem for this section. All right, so it says a food marketing institute found that 40% of households, let's see this, spend more than $200 a week on groceries. Assume the population proportion is 0.40 and a simple random sample of 145 households is selected from a population. What is the probability that the sample proportion of households spending more than $200 a week is between 0.35 and 0.45? All right, so our sample proportion is 0.40. I noticed that 0.35 and 0.45 are both the same distance away from the mean. All right, so remember this bell curve is symmetric. So if I find the area to the left of 0.35, this area to the right of 0.45 will be the same. Okay, so let's check that out. So I have 0.35 minus 0.40 over big square root 0.40, 1 minus 0.40, and that's divided by 145 here. Okay, so I'm getting z equals negative 1.23. If I change this to z's instead of p's, now I have negative 1.23. 0 would be in the middle. This should be positive 1.23. If you don't believe me, calculate it for yourself. 0.45 minus 0.40. This will be a positive 1.23. Okay. All right, so I'm going to find the area to the left of negative 1.23. All right, so negative 1.23. All right, so I have this area is 0.1093, which means this area is 0.1093. So to find the area in between them, I can do 1 minus 0.1093 minus 0.1093. Now in math, we would shorthand that to 1 minus 2 times 0.1093. And our final answer should be 0.7814. Okay. All right, there you have it.